So I talked about the processor optimization packs. This is where we, when we're developing the processors, simultaneously we are also developing optimization packages which go with those. So things like customized RAMs for level 1 caches for an A15, for example. Standard cells that after we have done multiple iterations of physical design, we have identified that some standard cells are called commonly, or if we had optimized versions, it would help with power and performance. We build those in. So these packs of physical IP are tuned to the particular silicon process and the particular processor. So you can get an A15 28 HPM optimization pack, for example. That's subtly different from an A7 28 HPM processor optimization pack, which then, of course, is subtly different to a 20 nanometer pack, for example. We talked about the A15 tape-out on 20 nanometer. We are currently developing, clearly, A15 processor optimization packs for 20 nanometer. But we don't just provide the standard cells and the memories. We also provide, as part of that, all the benchmarking data that we've worked through. And as part of having done that benchmarking, we provide all the implementation knowledge as well. So we provide user guides to end customers. We provide all the floor plans. We provide all the EDA scripts as well. So it's very easy for customers to take those optimization packs, take the processor RTL, and then roll out their own designs. I mean, each design may well be customized. Someone's going to do a dual, someone's going to do a quad. So every customer will optimize it in a different way. You can see two customer success examples, both on TSMC processors. So Panasonic took these optimization packs and got a very fast turnaround. I mean, we were quite impressed, actually, in terms of the fast turnaround they did and the speeds they're getting. So 1.4 gigahertz A9 on TSMC 40LP is a very impressive achievement. These processor optimization packs, I should say, are not just available on TSMC. They are available on some of the other foundries as well, such as Samsung and Global Foundries. I am in Hsinchu, so I'm focusing a lot on TSMC just now. If I focus down onto one of these components, the ARM memories, for example, we think we have industry leadership in that area. We have got a patented high-density memory architecture. We spent a lot of time working on this, and you can see some of the benefits that gives. So much smaller area, much smaller leakage, and as you know, in terms of lower geometry processes, leakage is rising as a contributor to total power. So we spent a lot of time optimizing the leakage there. And then significantly lower test time. And of course, that is a major contributor to final SoC cost. So we're optimizing across all of the vectors here, area, power, and actually test time or cost. These are available now. They're validated for a number of foundries on 40 nanometer and 65 nanometer. We're going to be taking that forward to 28 and 20 nanometer. And so I think so far I've talked about our CPUs, our GPUs, and our memories. And yesterday we announced one of the places we're going to bring that together. So it's here in Hsinchu. Yesterday we announced our newest design center. So that is going to focus on advanced SoC implementations. It has processor designers, it has GPU designers, it has physical IP designers. And they're all focusing on the next generation processors, GPUs, and advanced libraries. They are based here. We have a mixture of existing ARM staff and local hires. I think our first local hires are starting end of December or early January. And I'm very proud to be associated with this. It's our only hardware design center in Asia-Pac. We have a software design center in Shanghai, but this is the only hardware design center we have in the Asia-Pac region. And this will be serving customers in Hsinchu. It will be doing advanced developments and coordinating a lot of the work that's going on in the other ARM design centers, and it will be supporting customers in Asia-Pac. So I fully expect that this will ramp fast. Now, I'm going to finish on software, because as I think I've mentioned a few times, software is, of course, one of the key things we have to focus on. We can do a great job in terms of the hardware design, in terms of the implementation, making things performant and power efficient, but if the software isn't optimized, you can blow all of that away. It's quite easy to get a 10 times performance loss by having poorly tuned software. So we, as ARM, invest an awful lot of our R&D dollars, or our royalty dollars actually, in optimizations of software. And I'm going to show you a couple of those in a minute. So for example, in-house we have GNU development tool teams. So we have an M-profile tools team in Shanghai, optimizing GNU tools for M-profile designs. Clearly, we don't make any money out of the GNU tools as such. It's part of the investment we make in the ARM partnership. We also have a GNU team in-house who tend to work on the latest developments. So those are the people who are right now tuning the GNU tools for the A15 silicon we have back. Those are the guys who have started to develop the 64-bit GNU tools. And then what those teams do is they work in conjunction with Linaro, and they then release the GNU tools to them. Linaro further enhance them, they further maintain them. And then you can see that what Linaro also do is they take various partner systems and they try and coordinate things like power management and graphics frameworks across this. Because those are very different for each partner, for good reasons. I mean, partners try to innovate in that area, and they provide their own secret sauce, but it makes it very difficult and very expensive to port across all of those systems. So what Linaro is trying to do is come up with some standard frameworks. So a lot of this is, how can I put it, under the covers, it's hidden, you won't necessarily see it. What you will see gradually is you will see all of these innovations and all of these improvements going out into kernel.org. So a lot of these come out into kernel.org and then are downloaded and patched into things like Android. So a lot of this work is going on. And Linaro has got something like 100 engineers right now. In-house, we have about 80 software as well. We have about 80 software engineers focused on this area. And it's not just things like the GNU tools. That's a great example, but we also host boot for UEFI, for example. So we are the host of the ARM bindings for UEFI. UEFI is a boot mechanism for both Windows and Linux. And then we also have all the multiprocessor support and debug support. So a lot of this investment goes on. We occasionally talk about it, but I thought it was useful to share with you just now. Clearly, we are the leader in Android. We have 600,000 plus devices shipping on ARM every day, and that number is rising. So it's very important to us. I'm sure it's very important to you. So we have quite a few facilities available to you. We have the ARM Solution Center for Android. We have the Mali Developer Port to help you get Android running effectively on your GPUs. And we have very good tool support for Android as well. So our debug and trace tools are fully Android aware. As an example of that, we have the DS5 range, which will allow you to optimize your SoCs for multi-core development. And actually, it's quite cool. It allows you to do trace of the full SoC. So you can see the software running on the CPUs. You can see the software running on the GPUs. You can actually add plugins to this particular framework if you have your own custom accelerator. So if you have a custom video accelerator, for example, you can add that as a custom plugin to DS5. So as a software developer, you can actually see what the entirety of your software is doing on that SoC. And these systems are both Linux and Android aware. We also provide platform simulation models. So these are basically fast models of the processors. So you can get your software development environment up and running very, very quickly and running on emulated systems. So the end result of all this, I think, is we enable the ARM partnership to take the basic building blocks that we provide and innovate around it. So the partners will add their own value in different areas. That diversity brings choice. There are dozens of advanced SoCs. You can see some of the silicon partners we have up here. I think it was difficult to put all the logos up here. But each of the partners will take the basic building blocks that we provide. They will put their own value around it, and then that gives a lot of choice to the end users and the end OEMs. And that is the strength of the ARM partnership. It is the fact that we give you the basic building blocks or the raw ingredients, and you cook it in different ways. And as an example of how that innovation works, if we just again focus on the mobile space, you can see some of the wide range of different form factors that we have. And this, again, this is just the mobile space. So you can see how the innovation that you provide, based on the basic components that we provide, allows people to come up with completely different form factors in one space alone. So just in the mobile space, you have the tablets, you have the detachables, you have all the different smartphones. So this provides a vast amount of return and a vast amount of excitement to the consumers. And so to summarize, I think we're helping enable smarter systems. We provide integrated IP that works together. So the CPUs work with the GPUs, work with the interconnect, work with the physical IP. They're tested, they're developed, they're validated together, which reduces the risk and time to market for you. We do a lot of work collaborating with the industry, clearly with partners such as yourself, and across all of the software ecosystem. Some of that we talk about, some of that is under the covers, but there are hundreds of software developers working on that. We think by providing this, we're addressing the demands of today's designs and tomorrow's designs. I think I've gone through some of the technologies that will be coming out next year and the year after, and we still have 64-bit and some of the other technologies that I'm sure we'll talk about next year. And that allows flexible SoCs to drive diversity in end products. So I think it's a fair statement to make that the SoC, both hardware and software, is the system. So, thank you.